Okay, today let's take a look at functions. An equation written in function notation is written in this form. The function of x is equal to 7x minus 3. Don't let that scare you away. It makes perfectly good sense once we work our way through it. Let's take a look at some definitions to get started. A function is a relation where there is exactly one output for each input. Think about this definition. A function is a relation. What's a relation? Well, a relation is just any set of ordered pairs, okay? But in a function, that relation, none of the x values repeat, okay? So there is exactly one output for each input, which means no x values repeat. A discrete function is a graph that consists of points that are not connected. A continuous function is a graph with a line or a smooth curve. We're going to be dealing a lot with continuous functions because we're going to be doing the graph of a line. There's such a thing called a vertical line test, and this vertical line test says if a vertical line passing through the graph intersects the graph more than once, it's not a function. Well, okay, so we need a vertical line and we need a graph. So here we go. Here's our vertical line, and we've got 3 different graphs we can check to see whether they are functions or not. So as we run through our vertical line across the first graph, as you notice as it crosses through, it doesn't cross that blue line more than once at any given time. So as according to the vertical line test, this is a function. When we take it over and run it across the middle graph, as we go at the very first point, we're doing good, but from there on, what happens? Exactly, it's crossing the graph at 2 points, okay? This fails the vertical line test, so that means that this is not a function. It's still a relation, but it's not a function. Let's look at our last one here. This is a graph of a line, and as we go through here and run our vertical line across the graph, you'll notice that the vertical line touches the grass only in one place all the way across, which, according to the vertical line test, tells us that this relation is a function. Function notation. Well, if we have an equation and we have it written in slope-intercept form, y equals mx plus b, the only difference between that equation and writing it in function notation is what we put in for y. In function notation, we're going to have an f of x or a g of x to indicate which just replaces the y. They're interchangeable. It means the same thing. Y is the output. F of x is the output. It's the output when x is the input. Okay? Let's take a little further look at this and go way back now until grade school, and you had the function machines where you would drop a number in, it would go through the rule, and you'd get an output out. Okay? Well, let's give it a rule. Let's give ourselves the rule 2x minus 1. If we put 3 as the input, that 3 is going to drop down, it's going to go through the rule, and when it does, 2 times 3 is 6, minus 1 is 5, so our output on this one will be a 5. Okay? If we drop another number in, let's say we drop a 5 in, and it goes through our machine, as it goes through the rule, it does 2 times 5, which is 10, minus 1, so the output comes out as a 9. This is the way a function machine works. If the function machine functions, if we put a 3 in again and we get an output of something other than a 5, it's not a function, okay? Because if it's working properly, each time we put a different number in, we should get a different output. Let's take a look at finding the value of a function. Here's a function written as f of x, or the function of x, is equal to negative 4x plus 7. Remember, this is y, okay? So here's how it works. We're going to find the function of 2. we're going to find the value of the function if the input is 2. So we replace this x and that x with a 2 because that's our input. From here on out, instead of f of x, we're going to bring down the function of 2 because that's what we're finding. So when we plug 2 in, we have negative 4 times 2 plus 7. We simplify the multiplication first, which is negative 4 times 2 is negative 8. Add the 7, we have a value of negative 1. So the output, if the input is 2 in our function, the output is negative 1. Okay, let's take a look at this one. Let's see if we can work our way through. It's the same function, but we have a different input. This time we're putting in negative 3. So we know we're going to replace the x's with negative 3. We've got it plugged in both times. And if you remember, we can go ahead and, since we filled this in with 2's, we can go ahead and put that in, a negative 3 in each one, because we are finding the output if the input is negative 3. Over here, we do the math. Negative 4 times negative 3 makes a positive 12. 12 plus 7 is equal to 19. So in this function, if the input is negative 3, the output is going to be 19. And guys, these are ordered pairs. So we end up with ordered pairs because the input is x. The output, remember, I told you that this was replaceable by y. Well, y is the output. So we have an ordered pair here, x, y. We have an ordered pair here, x, y. Let's take a look at a couple more, well, actually 3 more. And I just wanted to show you here that sometimes, instead of f, they're going to have a g, and it doesn't matter. It's the same thing. We're finding the function of x. So here we're going to find the function of 5. So it means we're going to plug 5 into this function and see what happens. We're dropping a 5 into that function machine and seeing what number comes out. So since we're finding 5, we go ahead and put a 5 here and a 5 there. Remember, we know we're finding the function of 5, so we're going to go ahead and put 5 in here. 5 is our input. We're going to work our math. 3 times 5 is 15. So 15 minus 2 is 13. So in this function, if the input is 5, the output is 13. I wanted to show you something a little different here. And if we just think this through, it makes sense. This is saying, what is the function of negative 3 minus 8? Well, we've got to find the function of negative 3 first, and then we'll subtract that 8. So when we set that up, we're going to go ahead and plug it in. And notice I put our function of 3, I put that in brackets, so I know that this is actually the solution to the function of 3, and then I'm going to subtract 8 from it. So down here, well, 3 times negative 3 is negative 9. Go ahead and fill that negative 3 in. Negative 9 minus 2 makes negative 11. Fill that negative 3 in. And negative 11, take away 8 more, is negative 19. So for this function, if the input is 3, and I subtract 8 from the final, the solution of the function, my output is going to be 19. Got one more because it shows something just a little bit different. If you notice on this one, instead of, it says the function, doesn't say the function of 2, and it says the function of h plus 2. Well, this here represents the x part of it. So this is what we're finding the function of. The input is h plus 2. So I've got h plus 2 here, and I plug it in here. That means we're going to do 3 times the sum of h plus 2 minus 2. Well, we can't find the value for h plus 2 because we don't know what h is. But we can open up those distributive properties so we can go ahead and work through this. So if we use the distributive property, we do 3 times h, which is 3h, and 3 times 2, which is 6. So we have 3h plus 6 minus 2. Go on. Let's find our final solution for this. We can't do anything with the 3h, but we can combine our constants here. So positive 6 plus a negative 2 gives us a 4. So our solution to this is 3h minus 4. As always, I hope this helps. If you have any questions, be sure to reach out to me. Have a good one.